Now, exercise on momentum and momentum conservation. Our first question is, what is the momentum of 100 kilogram football player who is moving at 6 meter per second? Okay, this question is exactly just to remind you what momentum is. So, momentum, normally denoted with letter P, is equal to the mass times the velocity. So in this case, the football player's mass is 100 kilogram, okay, and times its velocity is 6 meter per second. So it is 600 kilogram meter per second. So momentum doesn't have a special unit or doesn't have a special name for its units. It's just kilogram times meter per second, mass times velocity. That's it. Now, question number 2. A car weighing 13,720 newtons is speeding down a highway with a velocity at 91 kilometers per hour. What is the momentum? Once again, it's the same thing. Momentum equals mass times the speed. But now, speed is given in kilogram per hour, but not directly meter per second. And also the mass is in mass is in no, it's not. It's given in weight, so which is not mass. So we have a problem. How do you relate to weight and mass? So the weight here given as weight is 1370 720 newtons. That's a gravitational force. That is equal to mass times acceleration, which is g. So from here we can derive what is actually the mass of this car. And the mass is actually equal to the weight and divided by the gravity, 9.8 meter per second squared. So I have explained the logic why it's so, because the 1 kilogram we will accelerate at this speed, and then therefore the force is divided by the force, or weight divided by force, you get the mass. So 1307.20 divided by 9.8, then you get the mass. Get the mass to be 1400 kilograms. That's the weight. Now the velocity, we need to convert it to meter per second. Although we are given as kilometers per hour, so 91 10 to the third, that's converting kilometers to meters, and 1 hour we have 3600 seconds, so that velocity is 25 meter per second. So we have mass and we have velocities, then the momentum is this. So this is 1400 times 25. Then we have the final momentum is 35 times 10 to the third kilograms per meter squared. So that's the momentum of the car. So directly apply the definition, mass times velocity, but we have to do a unit change. So only when you change the mass to kilograms and velocity to meter per second can you actually calculate the momentum in the standard unit. Question number 3. This is a interesting one. A 15-gram bullet is fired with a velocity of 200 meter per second from a 6-kilogram rifle. What is the recoil velocity of the rifle? Kind of mysterious. So think about this is something that's a rifle, and then they are together. So let's see, that's the bullet. So these two things, which means the force interacting between them, if this rifle pushes the bullet forward, and the bullet also pushes this backwards. So action equal reaction. Therefore, the total momentum of these two is constant. In other words, the total momentum is actually started at 0. So let's make this M of the rifle, the big one, is 6 kilograms. Okay, and also the mass of the bullet, I would say little m, is 9 or 15 grams, or but very small, 10 to the negative third kilograms. So that's the velocity. And what's their velocity to begin with? Everything stayed at 0, so velocity 1 equals 0. That's the rifle. Velocity 2, ever called the bullet, is also 0. Therefore, their total momentum is 0. So let me just spell them out. Total momentum before the shot. So momentum times 1, and plus a little momentum at 2, and you have 0, which means, so because mass 1 times 0 and mass 2, the bullet times 0, and it gives you 0. So that should equal to the total momentum of the second after the shot. So after, and then what is the velocity? And then you will see this total momentum, P, should be equal to mass times V1. I will put a prime. That means after the momentum. And plus the momentum of the little one, mass, which is 15 grams, times the velocity of 200 meters per second. Okay. So that's the total momentum. And so that should be 0, remain 0. And then what we don't know is we want to know its velocity. So now let's rewrite the math equation. So mass, the big M, is 6 kilogram times the unknown m1 prime, which means after the collision, the recoil speed, should plus this 15 times 10 to the third kilogram and times 200 equals 0. Then this becomes an equation with one known, which is v1 prime. That is the velocity of the rifle after the collision or the shot. So in other words, if you solve the equation, and then v1 is actually equal to negative . Okay, number 4, a car traveling at 5 meters per second rear ends collides with another car in front. If the two vehicles getting stick together and move ahead, what will be the speed? So if you look at the picture, two of them hit each other, but after that they are together and we're moving away with a slower speed. Okay, and then this is again a momentum conservation problem. Okay, before the collision, mass of the object times 5, that's the momentum. And then the other car, which is actually supposed to be slow, or maybe we can assume its velocity is 0, mass times 0. And after the collision, and it should be equal, we should have the same momentum, and mass plus mass, which means 2 times of the mass, and velocity and 2 primes. So if you solve for the later velocity, it is 5 divided by 2 is 2.5 meter per second. So this is understandable. Think about it. One is slow in front, the other one is faster, and they become together. So mass becomes twice and of the whole unit. Since the momentum has to be conserved, so the velocity reduced to half.